Sprinters have amazing acceleration, but they can cover a greater distance in a shorter period of time if they get to have a running start. So now we're going to continue to look at formulas to calculate displacement during accelerated motion. So sometimes using graphs is not practical, so displacement is calculating using formulas instead. So we've already seen displacement equals velocity multiplied by time, but that only works if you have a constant velocity and time was given to you in the question. Sometimes, since uniform motion is rare in the natural world, there's a necessity to use some new formulas. So when you're not given the distance value in question, but you know the initial and final velocity as well as the time, or if you know the initial velocity but no final velocity, the acceleration of the object, and the time interval. So we have two different formulas that we can rearrange here. So these formulas are given to you in your data booklet, and we're going to manipulate them to solve for the different variables. Now, what you do to one side of the equation, you must do to the other. So I'm going to just, and I don't have room to go through all the steps here, so I'm just going to do the final one. So delta t is equal to the displacement divided by initial velocity plus final velocity divided by 2. Okay, so what I did was I divided both sides of the equation by the initial plus final divided by 2. Now to rearrange this equation to solve for initial velocity, okay, the first thing we're going to do is take our initial velocity. We have delta d divided by delta t. Now we have to multiply both sides by 2, and then we're going to subtract our final velocity. So initial velocity equals 2 multiplied by the displacement divided by time, subtract our final velocity. Okay, and so now lastly, final velocity is going to look quite similar. Again, these are all vectors. Is equal to 2 multiplied by the change in displacement divided by the change in time, subtract the initial velocity. Okay. So those are the variations of this formula. And if you have most of the information in that formula minus one of the variables, you'll know that that's the right one to choose. So going through an example, a car accelerates from 17 meters per second to 28 meters per second in 10 seconds. What is the displacement of the car? So we have our initial velocity, our final velocity, and the total time. So we're going to look for displacement. Okay, so there's our formula. Putting our numbers in, 28 meters per second. We can go plus 17 meters per second divided by 2, all multiplied by 10. Then we get 225 meters as the total displacement. Now, using this again, a car driving at 40 meters per second sees a radar van and slows down to 30 meters per second in 8 seconds, just in time to pass the van and avoid a ticket. How far was the radar van away when the driver spotted him? So our final velocity was 30 seconds. Our initial was 40. We're going to add those together, divide by 2, and multiply by 8. So a total of 280 meters. Now, our second displacement formula works if we have initial velocity but no final velocity, acceleration, and time. So again, we can manipulate these two equations to solve for initial velocity and to solve for acceleration. So initial velocity is equal to, so first I'm going to subtract this half of the equation from both sides. So displacement, subtract 1/2 a t squared. And I'm going to then divide both of this by the change in time. So I have that equation. Now to solve for acceleration, I'm going to subtract both sides of the equation by this by the initial velocity component. So we have acceleration is equal to displacement, subtract the initial velocity, multiplied by time. This will all be divided by the change in time squared, but we have to get rid of this half, so the whole thing is going to get multiplied by 2. So acceleration equals 2 times the distance minus initial velocity multiplied by time divided by the change in time squared. So a ball traveling at 1.75 meters per second starts rolling down a ramp, which causes it to accelerate at 0.5 meters per second for 1.5 seconds. How long is the ramp? So putting our known information in, we have 1.75 meters per second times 1.5 seconds, our total time, plus 1/2 times 0.5 meters per second squared, the acceleration, multiplied by 1.5 seconds squared, giving us a total distance of displacement of 3 meters. Now, lastly, a rock is dropped off a cliff and falls for 7 seconds before hitting the ground. How tall is the cliff? So now it's dropped, so that's going to mean our initial velocity is 0 second, and falling means our acceleration is gravity at negative 9.81 meters per second squared. So we're going to put this information in. 0 meters per second times 7 seconds, plus 1/2 minus times negative 9.81 meters per second squared, downwards, multiplied by 7 seconds, gives us a total displacement of negative 240 meters downward. So the cliff is 240 meters tall. Now, I know that working with these formulas can be a little bit complicated, but know that you have a lot of options when it comes to your formulas. They're all in your data booklet. So the first place to start is always to write down your list of known variables and then choose the most appropriate formula for your equation.